Hi, this is Math 6, Lesson 1. But before we do Lesson 1, let's do an overview of Topic 5. Topic 5 is Understanding and Use Ratio and Rate. In this topic, we'll think about what the ratios and rates are, how we can use ratios and rates to describe quantities and solve problems. We have 10 lessons total. It's a big topic. So, but it's okay, we'll do one by one. First, let's look at page 263 and review what we know. First, vocabulary. Choose the best term from the box to complete each definition. We have common factor, common multiple, equivalent fractions, and fraction. Okay, we learned about these vocabularies in our previous topic. Number 1, fractions that name the same amount are called, they're the same amount, equivalent fractions. The number 3 is a blank of 9 and 12. How is 3 related to 9 and 12? It's a factor and it's a common factor. They both have 3 as a factor, so it's called a common factor. Number 3, a number that can be used to describe a part of a set or a part of a whole is a fraction. Okay, do you know equivalent fractions? Write two fractions equivalent to a given fraction. It doesn't have to be this, but there are many answers for writing equivalent fractions to these ones. But the smallest two will be for number 4, 3/4 is also 6/8, and it's also equal to 9/12. You multiply by 2 on both numbers, or you multiply by 3 on both numbers. Okay. Number 5, 7/8, multiply by 2 on both one, you get 14/16, multiply by 3, you get 21/24, the equivalent fractions. You can also multiply by decimals, but bigger numbers, but make sure you multiply the same numbers. Number 6, 24/10, 120/50. Number 7, 2/4 or 3/6. Number 8, 16/18 or 24/27. Number 9, 6/9 and 8/12. Write an equation that represents the pattern in each table. Do you see any pattern? There's a relationship between x and y. For every increasing number of x by 1, how much does y increase? 16 becomes 24, becomes 32. So you're adding 1 each time for x, but you're adding 8 each time for y, right? So this could be written as x times 8. 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, and so on. So you can write an equation, y equals 8x. Okay, number 11. For every increasing value of x by 1, your y increases by 2. Can we write this as a multiplication? Not really. But how do we know where we start? Well, whatever x is, compared to x, y is always plus 3, right? So you can write that as an equation. Y is equal to x plus 3. Units of measure. Choose the best unit of measure by writing inch, foot, yard, ounce, pound, ton, cup, quart, or gallon. Okay. This, you might not be familiar with it yet, but usually if you have a serving of trail mix, okay, when you do baking, you will usually, in the States, use a cup for measurement. Number 13, height of a pension. In Asia is usually meters. Okay, but in the States, it's usually going to be feet or inches. Weight of a newborn kitten. In Asia, again, so meters, weight is going to be kilograms in Asia or ounce in the States. Gasoline will be gallons in the States, okay? Or also liters in Asia. Number 16, Michael is 4 feet tall. Explain how Michael could find his height in inches. Okay, then explain how he could find his height in yards. So we know that 12 inches is equal to 1 foot and 3 feet is equal to 1 yard. So using the conversion unit, we'll convert 4 feet into inches by multiplying the conversion factor. Because feet is where we're starting off from, you put the denominator as a feet. 1 foot is equal to 12 inches. So that feet cancels out and you multiply 4 times 12 in order to get inches. And then how do you find the height in yards? 48 inches will be, you're gonna start with 4 feet. 48 inches would be 4 feet. So 4 feet times, again, 3 feet in the denominator and 1 yard, so that you can cancel out feet. And then you have yard as a remaining unit. So 4 feet is equivalent to 4 over 3 yard. Okay, so you would want to explain that. Use the conversion units to convert. Okay, that was a review of the skills that you need for this topic. Now, what about the language? Okay, let's look at some vocabularies. A bag contains the following marbles. We got 3 red marbles, 2 blue marbles, 6 yellow marbles, 4 green marbles. Complete the math statement. The following ratio statement reads, for every 1 red marble, there are how many yellow marbles? You got 3 red marbles and 6 yellow marbles. So that's a ratio, 3 to 6. But if that becomes 1, how many yellow marbles do you have? 2, right? 1 to 2 will be equivalent ratio for 3 to 6. What about a ratio that compares the yellow marbles to the green marbles? Is 6 yellow to 4 green, so 6 to 4. Or you can simplify that to 3 to 2. Okay, either way. 3 to 4 is the ratio of red marbles to blank marbles. 3 to 4. 3 is red. 4, we only have 4 in the green. So it should be green marbles. Okay. The following ratio statement reads, for every blue marble, there are 2 blank marbles. For every blue, there are 2. So 2 dot something should be 1 to 2 ratio. They should be equivalent. So 2 times 2 should be 4. So that is green. For every 1 blue marble, there are 2 green marbles. Okay. 3 over 2 represents the ratio of marbles, of red marbles to blue marbles. 4 to 15 is the ratio of green marbles to the, what's 15? Total number of marbles. Okay, in the ratio of yellow marbles to blue marbles, 6 to 2, the quantities of 6 and 2 are called these are called the terms. It's a vocabulary word. The last one, a blank, compares one blank to another blank. So generalize the concepts. Ratio compares one quantity to another quantity. Okay. So that's the language part that you need for this topic. Let's see 5.1. In this lesson, we'll be able to use a ratio to describe the relationship between two quantities. And it's all about understanding ratios. Let's look at Explore It. A band just released an album that contains both pop songs and R&B, rhythm and blues songs. Best of the 90s. We got pop lists and R&B lists. How can you describe the relationship between the number of pop songs and the number of R&B songs in the album? How many do we have? We got 9 pop songs and 1, 2, 3, 4, 5, 6 R&B songs. Okay, so it's 9 to 6, right? So what is the ratio? There were blank pop songs for every blank songs is what we want to write. Nine to 6. If you simplify, you divide it by 3 on both sides. You get 3 and 2. For every 2 pop songs, you have 2 R&B songs. Part B, how does a bar diagram represent the relationship between the number of pop songs and the number of R&B songs? We got pop songs, 3 bars, and R&B songs, 2 yellow bars. So what does each section of the bar diagram stand for? Okay, so three pop song for every 2 R&B songs just gives you a ratio. But how many total are there? We have 9 total pop songs and 6 total R&B songs. So each bar represents how many for pop songs? 3. So 3 times 3 would be 9. 3 times 2 would be 6, right? So each section represents 3 songs. Focus on math practices. Another album has 2 pop songs and 10 R&B songs. Draw a bar diagram. Draw a bar diagram that you could use to represent the relationship between the number of pop songs and the number of R&B songs. So pop songs and R&B songs, you have 2 to 10 ratio. So how can you simplify that? You can divide both numbers by 2, 1 to 5, right? So pop will have 1 bar, R&B will have 1, 2, 3, 4, 5 bars. And each bar represents 2 songs. 2, 4, 6, 8, 10. Okay? So that's a diagram. Let's look at example 1. Throughout this lesson, we'll think about what's a mathematical way to compare quantities. Write ratios to compare quantities. Tom's Pet Service takes care of cats and dogs. Currently, there are more dogs than cats. Compare the number of cats to the number of dogs. Then compare the number of cats to the total number of pets at Tom's Pet Service. So the ratio, again, is a relationship in which for every X unit of one quantity, there are Y units of another quantity. So ratio can be written in 3 ways: X to Y, X dot dot Y, and then X over Y. They are all the same ratio. So first, we're going to use a ratio to compare the number of cats to the number of dogs. 14 to 17. 14 dot dot 17, 14 over 17, they're all ratios, equivalent ratios. Use a ratio to compare the number of cats to the total number of pets. 14 plus 17 is 31. That is our total number of pets. Right, so 14 to 31 would be our ratio. So let's try the try question by yourself. Come back when you're ready for answers. What are the 3 ways to write the ratio of the number of dogs to the total number of pets? So the dogs are 17 to total number is 31. So 17 to 31 is one way. Another way, 17 dot dot 31. You read 17 to 31. And then you have 17 over 31. Okay. Is the ratio of dogs to cats the same as the ratio of cats to dogs? So dogs to cats will be 17 to 14, right? What's the ratio of cats to dogs? 14 to 17. Well, in fraction, that's equal to 17 over 14, and that's equal to 14 over 17. Are they equivalent? No, 17 over 14 is not equal to 14 over 17. They're not equal. Okay, 17 over 14 is going to be a greater ratio. Let's look at example 2. Use a bar diagram to solve a ratio problem. The ratio of footballs to soccer balls at a sporting goods store is 5 to 3. If the store has 100 footballs in stock, how many soccer balls does it have? Use a bar diagram. We see 5 to 3 balls, right? And using the ratio, what if we have 100 footballs? So every 5 footballs, we have 3 soccer balls. So we need to see how many 5s go into 100 to multiply the same amount. 5 times 20 is 100, right? So each bar could represent 20 instead of 1. And so that makes this bar 20 as well. So 20 times 3 is the amount of soccer balls when you have 100 footballs, which is 60. Example 3. Use a double number line diagram to solve a ratio problem. Chen can ride his bike 3 miles in 15 minutes. At this rate, how long will it take Chen to ride his bike 18 miles? So you can use something called a double number line diagram. Okay. You can draw 2 arrows, each representing different things, miles and minutes. And then for every mile, he's going to go at a certain speed, right? So every 3 miles, he will spend 15 minutes, right? So he will bike 6 miles in 30 minutes, 9 miles in 45 minutes, and so on. You can count 3s for miles, you can count 15s for minutes, and so you can go on until he hits 18 miles. That's going to take him 90 minutes. Okay, this is a visual way to show and represent the ratios. Let's try this problem on the bottom. Come back when you're ready for answer. Chen's friend Alyssa can ride her bike 2 miles in 7 minutes. Use a bar diagram or a double number line diagram to find how long it will take Alyssa to ride 10 miles if she rides at the same rate. Okay, so miles and minutes. 2 miles in 7 minutes. Okay, so 4 miles, 7 times 2 is 14. And then 6 miles, 21. 8 miles, so you add 2 each time for miles. And then for minutes, you add 7 each time. How long would it take Alyssa to ride 10 miles? 10 miles would be 35 minutes. Okay. All right, so you can use a ratio to solve this problem as well, but this is how you can solve it using the double number line diagram. So that was lesson 1, understanding ratios. The ratio compares 2 quantities. To summarize this lesson, a ratio can be written in 3 ways: something to something, and then something dot dot something or something over something, right? Make sure x to y, x dot dot y, x over y, the order stays the same. And these are two types of visual representations. You can represent the ratios. That was 5-1, understanding ratios. Okay, I'll see you in the next lesson in the next video. Bye.